Greetings and welcome to The Drowsy Scientist. If you're new, I make you feel at ease. Curiosity-driven investigations into scientific marvels that aim to make you a bit more inquisitive than you were previously. And welcome back, dreamy voyager. If you've been here before, it's nice to see you again. Tonight, we'll glide gently through the atmosphere of Earth and into a world where up and down lose their significance. And the land is in good condition. We're going into space for optional reasons, not to experience the excitement of rockets or the buzz of launch control, but to investigate a more profound, silent, and much more. The force that keeps your feet on the ground is called mysterious gravity. You can't get your tea off the table. The silent sculpting of galaxies and stars. What if you could avoid the regrettable situation where your toast ends up jam-side down? Take a brief break from it to experience the universe without gravity pulling at your sleeves all the time. In this video, we're going to examine what we may actually learn about gravity by floating in a vacuum, what happens to how gravity affects our bodies and thoughts, astronauts in orbit, and how Einstein flipped the entire idea on its head in a way that is polite. And I should definitely tell you that this video is harmful, so perhaps it's sleep-friendly now. Educational. I'll try not to make it too captivating, but if you can't stop thinking about the space-time warping, but at least you'll be learning something that's a fair exchange for a few lost zingers before to debut. But I'd really want a small favor from you if you appreciate the cosmic journey tonight. For more wondering, think about liking this video and perhaps becoming a subscriber to Science and Slippers. Minds wander around here, and if you want to share, please let me know in the comments. What time is it right now, and where in the world are you watching from? Now, there's something strangely reassuring about picturing individuals from all over from Sydney to Stockholm, from midnight to dawn, enjoying a cup of tea or sliding beneath the blankets, all of them united by a love of soft things and a common curiosity. Science and silent stories right now. I hope you're comfortable wherever you are. Perhaps you've turned off perhaps your cat has already switched on a star projector or fluffed up your pillows. If you're snoring wherever and however you're listening, I encourage you to calm your breathing, relax your body, and clear your head. Wander about a bit. We're just floating here and not in a rush, since there is simply motion curves and silent. Humans in space, neither up nor down, say that being in microgravity is both free and confusing because you can flip, twist, and float in place. Yet with just a little push, you can glide across a room, and everything. The gimmick we're using is that even though it doesn't seem like it, the area around you is still heavily influenced by gravity. Tonight, we will investigate the idea that weightlessness isn't the absence of gravity, but rather the existence of an unfamiliar constant fall, flawless motion, and a sort of cosmic sleight of hand, and to realize that we will need to go to the International Space Station, as well as the Newton and Einstein's thoughts on the attraction of black holes and their strange consequences. The human body is affected by gravity, but we'll proceed cautiously. This isn't a rocket launch. Slowly, it drifts into the invisible web from Earth's atmosphere that holds the cosmos together. So give the surface below you one last glance. Feel the force of gravity holding you down wherever you are seated or lying. It has been there for you since the day you were born, a soft touch on your back. Yet we'll spend the next few minutes imagining what it would be like to release that hold, soar past it, and observe what mysteries gravity has long kept us in the dark about, because occasionally the leaving things behind for a while is the greatest way to grasp it. Okay, drowsy scientists, let's start our voyage by floating in space. Teaches us about gravity. Therefore, let's start by explaining what gravity is. Questions that appear straightforward until you actually attempt to respond to them. You may say, well, it's what pulls things down. While that isn't incorrect, it's true that sleep occurs when you close your eyes. However, there is more to come. So let's begin at the beginning rather than the Big Bang beginning. As we ease into this, let's go back to Sir Isaac being hit by an apple. Newton's head, but, spoiler alert, at least the apple didn't strike him. Most historians disagree, but it did make him reflect about Newton in the late 1600s. Suggested that objects with mass were pulled by an unseen force called gravity. You, I, the moon, your dog, and we all pull on each other just by exerting ourselves. The Earth pulls more stronger since it is large, round, and full of itself. According to Newton's laws, this explains why you fall down rather than sideways when you trip. Something's pull is stronger when it has more mass, and the closer you are to it, the larger the effect, which is why the sun's enormous power holds the planets in orbit, and we're fortunately not hugging each other. We're simply a Newton's model, which allowed us to forecast comfortable 93 million miles. It was excellent. How to shoot cannonballs farther, how planets revolve, and how apples fall. It lasted for more than 200 years, your neighbor. But then Einstein arrived with bright gleam in his eye and a penchant for inverting things. Einstein released his The Theory of General Relativity as a fascinating concept that saw gravity as a type of curvature in space and time rather than a force. Considered the universe to be a flexible cloth, and then set a bowling ball on it. The sun, which causes a dent in a neighboring marble. Much like the Earth, and the marble will spiral inward as a result of following the fabric's curves rather than being dragged. In other words, gravity is just the way the Earth moves. It is not something the sun does to it. Planets aren't being tugged through the bent space-time the sun creates. Now this is a section of the universe where they are simply traveling in the most direct route conceivable. Script where your pillow may begin to feel too heavy, but don't worry. Allow Newton claim that even if the space around you doesn't float, your thoughts do. Einstein claimed that gravity is a force and a characteristic of geometry, and both are correct. Newton's equations, in their own unique ways, are ideal for commonplace objects like vehicles, satellites, and falling when strange black holes appear. Einstein's model comes into play. Yes, you heard correctly. Bending around stars or a tiny slowing of time on GPS satellites, stronger gravitational fields cause your head to tick differently. This has been measured, just enough to make physicists, but not quick enough to allow you to time travel or anything. GPS engineers are anxious and quite excited if this is all beginning to sound. I assure you that, similar to science fiction, we are still in the established space, time, light, and even your sense of direction are all impacted by science gravity. The reason International Space Station astronauts feel weightless is not because gravity has disappeared, but rather because they are always descending freely, circling the Earth rather than entering it. Like being trapped in an endless loop of a roller coaster, yet gravity isn't simply about falling, it's about order. Without it, planets and stars wouldn't develop. Orbit, even your body's bones, muscles and fluids wouldn't remain in your chair, are molded by the ever-present whisper of gravity. In fact, gravity is so profoundly ingrained in our life that we hardly notice until it disappears, at which point things start to seem odd. Your spine flexes, your equilibrium deteriorates, your fluids begin to float, and your brain blesses as it attempts to make sense of a world free of depressive disorders. Get to all of that shortly, but for now, just allow this notion to slowly permeate your. Not only does mind gravity pull, but the silent choreography of the universe provides instructions on how to travel, when to stop, and where to orbit, which controls moons, galaxies, tides, and seasons. But it never makes it is the most kind ruler and possibly the most vital. So keep that in mind the next time you feel your body sink into your mattress. That is gravity securing you, not force or flare, but simply silent global perseverance. And don't worry if you're still awake, there's still a lot of wonder. We'll go past the abstract in the upcoming chapter and into the world of astronauts, where gravity still exists but floating feels like flying. You've made it to space, so let's float on behind every curve. You are currently floating after, leaving the atmosphere and feeling the pull of Earth's gravity below. Arms extended, a slight spin, a slight tumble. Perhaps it seems magical when the pen slowly moves past your nose, but here's the oddly enough, you're not truly weightless. Hold on, that's correct. Gravity hasn't left leave of you, despite how it feels. Actually, even on the approximately 400 kilometers above Earth, the International Space Station's gravity is still around. The reason astronauts float isn't 90% as powerful as it is on the surface. Since gravity no longer exists, they are in a state of perpetual freefall. Let's clarify that in the most drowsy way imaginable. Picture yourself on a towering roller coaster. The car disconnects at the very top as it brushes against the border of space, and instead of as it falls straight down, it travels at a speed of about 28,000 kilometers per hour. Falls. The Earth's curve disappears beneath it at the same speed that you fall, but never make contact with the Earth. You are orbiting, not hovering, as astronauts do. They have been plummeting sideways since the beginning, quickly enough to completely miss the Earth. Since the rocket launched them into orbit, what does zero gravity mean? What we truly mean by microgravity is not the lack of gravity, but rather the sensation of weightlessness while being affected by gravity. Is a useful parallel to consider being in a very unfortunate elevator. The cables break and the elevator starts to plummet. Everything inside appears to float. The apple you were in for a few horrifying seconds. Everything drifts next to you while you're holding your teacup. Nothing is pushing back against your weight since you haven't escaped gravity and are simply falling at the same pace. On the ISS, that is what is occurring. But without the fear and with much improved snacks, astronauts spend months at a time living and working in this state. And even if it seems like fun, you've undoubtedly seen kids chasing flying M and Ms and flipping around. But there are a variety of odd outcomes. For one thing, your inner ear becomes confused because it depends on gravity to indicate which direction is up. And your brain says when that signal stops, well, this is a weird dream. Initially, nausea is more prevalent than running into Newton's rules come to life in microgravity. Every action has an equal and reverse reaction. You will fly across the module if you push off a wall, perhaps into someone else's floating meal. Even the most basic chores turn into an adaptation exercise. Picture brushing your teeth and the toothpaste attempting to get out, or utilizing a restroom without the advantage of having items remain in their proper places. Astronauts must learn to eat, sleep, and move around as if they were on Earth had never instructed them. And astronauts don't require pillows when they sleep, or mattresses. They actually float inside sleeping bags that are attached to the wall. Some report they are tossing or turning, simply floating peacefully in a quiet cocoon of silence. Others don't sleep as well in microgravity as they do, but It's the best sleep they've ever had. Your body turns into a new experiment where fluids redistribute without gravity pulling you down, causing your face to swell. Your sinuses may feel permanently clogged, and your legs may become slightly smaller. Space face is the technical name, and it's not as glamorous as it seems. Muscles deteriorate without gravity pushing against them, and bones start to lose density. Your body no longer has to fight against that steady downward pressure, so it doesn't. Which is why astronauts work out twice a day to maintain their Earth strength prevents your spine, muscles, and bones from becoming softer. While in orbit, some astronauts naturally grow up to 2 inches taller. When they return to Earth, they shrink back down. But it's a pleasant temporary benefit unless you already barely fit in your seat. However, the most fascinating aspect of microgravity may not be what it tells us about the profound ways in which gravity molds the body. We take for granted that things fall in all we do on Earth. Water drips down, keeping the food on the dish and your chair on the floor in space. Everything changes, and the guidelines are water that has been overwritten creates floating blobs that adhere to surfaces and float like little food for jellyfish needs to be sealed and mushy or sticky to prevent choking hazards. You lift yourself hand over hand through the air rather than walking anyplace. Modules. There's simply where your feet are attached. There's no down. Astronauts frequently explain their few days in orbit as physically and mentally confusing. But eventually as microgravity becomes the new normal, brains develop new behaviors. Things start to go strange again when they get home. Astronauts have been known to trip over equipment, forget things, and be unable to let go of them. Some people naturally release a pen and anticipate it. One cosmonaut claimed that when attempting to turn over, he nearly floated out of bed. Therefore, it would be more correct to say that your body feels weightless while floating in space. Yet gravity never left the room. It continues to tug, but not in the familiar manner. And behind that subtle bewilderment is a form of beauty, since it serves as a reminder that gravity is something we've created, not merely something we have to live with. Everything about us, including our muscles, bones, routines, and innovations, if you take it away. Even for a little while, the world turns into a beautiful, moving dream. And odd new regulations in a realm where gravity still exists, yet floating feels like flying, silently leading you and constantly tugging. Even when you don't feel. We'll delve further into life aboard the International Space Station in the upcoming chapter. How do astronauts aboard the station eat, tidy up, and on this floating planet? And what creative fixes have engineers created for a location where everything, despite the crumbs attempts to flee, gravity's pull has been overcome? Discovered that floating isn't actually weightlessness. And now we're at a really weird place inside the 6 people at a time. A spacecraft, a laboratory, and the International Space Station from the outside. A floating house circles the planet every 90 minutes. The ISS resembles a futuristic tin can with solar wings. Yet on the inside it's an intricately designed dance of floating figures, softly blinking devices, and though unglamorous, the hum of recycled air is subtly. How do you manage to survive in microgravity without everything floating into space? Chaos. Let's begin by discussing how easy it is to eat on Earth. Gravity handles the heavy lifting, keeping your soup in the cup, your drink in the cup, and the food on the plate, bowl in space. Nothing works. Food crumbles, drinks float, and stray pieces of because tortillas can turn lethal if they fall into a ventilation fan. Different. Meals for astronauts are packaged in airtight pouches. Drinks are drunk using clamped straws, magnetic spoons, or fastened on or velcroed in some way, since misplacing your silverware in the middle of a meal is unexpectedly simple as it moves around. Fun fact: tortillas are favored over the reason bread floats in space is because they don't make crumbs. Crust may get into your eyes, nose, or worse, within vital electrical air. And cornflake on microgravity panels is essentially a imagine sleeping in space villain. You don't lie down. There isn't a down. Astronauts zip themselves into tiny cabins the size of phone booths to sleep in. Inside, sleeping bags attached to a wall, ceiling, or other surface that feels comfortable with no weight on your joints or strain on your back. Most astronauts describe floating as being like being enveloped in a gentle cloud and not having to toss. No twisting, only a mild suspension. Albeit sometimes someone forgets to. Sleepwalking is difficult because they zip up correctly and float around like a wood balloon until they run into something. Personal hygiene baths, no showers available when there is no floor. You can't stand beneath water because it doesn't fall in space. Instead, astronauts you squeeze out a glob of water to wash using rinseless wipes and no-rinse shampoo. Grab it from a pouch and massage it on your arms or face. The water sticks. By the way, a jelly bubble is actually more of a sponge bath floating toilet. There is no gravity to help things along, thus they deserve their own medal. Airflow and a vacuum system are used in space toilets to remove all waste. Must be directed extremely precisely. Astronauts wear thigh harnesses, foot restraints, and meticulous instruction. A handbook, practice, and yes, it's uncomfortable. Yes, today's coffee is made from urine that has been purified and turned into drinking water. The tagline for yesterday's NASA is today's Gatorade is yesterday's pee. Not only is it resourceful, but each critical water launch is weighty. Drop counts, but astronauts move by floating rather than walking. In theory, they push off with their hands and move through the small modules with grace, but in practice, it's more like deliberate bouncing, colliding with walls, twisting in midair, and missing the handrail and doing a sluggish, ungainly turn while attempting to maintain control. They utilize handrails, foot loops, and a ton of Velcro for everything. Clipboards that are labeled and glued down, computers that float, pens that float, and you don't put "let's talk about everyday routines now." You can connect anything to it or it will float off like a stubborn balloon. Astronauts work 12 hours a day, 6 days a week, with planned breaks, to the smallest research experiments, repairs, and communications with the ground control and exercise. Keep in mind that muscles and bones deteriorate in microgravity. In order to combat this, astronauts need to exercise for almost 2 hours every day. That involves using bungee cords to imitate body weight resistance while running on a treadmill, training, cycling, and even a space gym. But it's a little noisy and it keeps astronauts grounded and in shape. Yet it looks more like a medieval torture device than a center for wellness. In a metaphorical sense, people can unwind after work, watch movies, make video calls, read, or specifically gaze out the window with their families. The cup is an observation dome with 7 windows that provides breathtaking views. Imagine witnessing lightning every 45 minutes as the sun rises and sets over Earth. The tiny blue line of our towns is illuminated by storms from above, which glow softly in the night. The delicate and exquisite environment is enough to cause even the most experienced astronauts to pause and gaze. Many claim that it's the station's most serene area, a sort of hallowed nook, reminder of their original purpose for being up there. But even with the wonder, space life is difficult. It's claustrophobic, noisy, with constant fans, pumps, and beeps. You float into each of the 5 people who share your bathroom, which gives you little privacy. The food, well, let's just say you don't go to other people's personal space a lot. The majority of astronauts still characterize their time in orbit for the food as transformative, not only due to the science or the vista, but also to the lessons it imparts about life on Earth. We frequently take for granted things like fresh air, water, privacy, and gravity. Granted, become valuable in space, where each breath is a gift and every drop counts. Engineering and seeing our tiny, solitary, light blue dot in the great deep down darkness can change something. Living in microgravity isn't merely a technical difficulty. It serves as a lesson in humility, perspective, and flexibility. In our next chapter, it turns out that floating teaches us a lot about being human. We'll examine the effects of space travel on the human body, not only the transient edema and strained spines, but also the deeper biological impacts, how our evolution has been affected by gravity, and what occurs when we go too long without it. So take a deep breath and allow your limbs. You're still grounded, yet for a brief while, picture the soft hum of a floating laboratory, the Earth gently rotating underneath it, and the wonder of life in so far. Orbit seems like a dreamlike place with no gravity and no hurry. Float from one work to another like a ballerina underwater, while the Earth below shines like the galaxy's nightlight. Although your hair's always naturally full, but despite all of its beauty, there is a calm expense, and we'll investigate what microgravity actually does to the human body's peculiar changes, unexpected difficulties, and concealed how gravity has always shaped us, because this is the key: that the body is accustomed to gravity and has been dancing with it ever since. Gravity instructs your muscles when to flex, your bones when to grow, and you were born without that continuous, imperceptible tug. Your body begins to ask where blood should flow. Wait, what are we doing? Let's begin by making a little flowing change. Blood, water, lymph, and other body fluids are drawn downward by Earth gravity. This explains why standing for extended periods of time causes your feet to swell, and why lying down in space causes your sinuses to feel clear. Your face gets puffy when your fluids go upward and redistribute. Astronauts frequently refer to these oddly thin legs as the Charlie Brown effect. Your voice alters, your sinuses fill up, and your head is little. And this fluid movement also causes your body to appear as though it is wearing an invisible pressure suit backwards. Something called SANS, spaceflight-associated neurocoolers, in your eyes. This may result in a buildup of pressure behind the eyes, which may flatten the eyeball slightly and have an impact on some astronauts' eyesight changes over time after they return to Earth. Perfect for jobs that require you to read checklists and avoid slipping into walls. Speaking of walls, your bones, because even standing motionless is a workout, but muscles aren't accomplishing anything up here on Earth. Your skeleton reacts when your legs support your weight and your back keeps you upright. Pressure by remaining robust. But since there is no weight or pressure in space, your bones start to deteriorate. In reality, astronauts lose between 1% and 2% of their bone mass density every month in orbit, which is equivalent to 10 years of aging in a few months. Particularly susceptible are the hips and lower spine, where calcium leaks out of the bones and isn't always replaced. completely when you get down to Earth. Your muscles, especially your quadriceps, suffer. Without regular exertion, calves' backs diminish quickly, which is why astronauts have such intense exercise regimens 2 hours a day, 6 days a week. This isn't just for show. Returning to Earth without exercise would be like attempting to run a marathon after spending a month in bed. In microgravity, your heart doesn't have to struggle to beat even if it becomes a little lethargic. Pump blood upward, the heart's workload decreases, and it may contract a little when astronauts return they can experience lightheadedness or vertigo because their cardiovascular system has forgotten how your vestibular system, the area of your inner ear that regulates balance, helps you cope with gravity, becomes perplexed as well. It utilizes gravity to determine which way is up. Thus, while in orbit, it essentially raises its hands and declares, "You're on your own." This is one of the reasons astronauts frequently encounter headaches, dizziness, and space motion sickness during their initial days in orbit. Nausea isn't really the typical sci-fi hero lifestyle. And then there's your back's vertebrae relax when the compressive force of gravity is removed. It sounds fantastic until astronauts grow up to 2 inches taller in space as a result of this minor separation. You recall that they are in a metal tube made for those who are 6 inches or less. The biological changes aren't all bad life, but being cramped in your sleeping bag isn't exactly as beautiful as it sounds. In space has enabled us to comprehend how gravity influences every aspect of human growth. It has shown us that muscles don't just build, they also react, grow, they adjust, and even our cells act differently when in orbit due to modifications in the immune response. Gene expression and the various ways that wounds heal are the most important laboratory. And these insights apply to more than just astronauts. Doctors can better comprehend osteoporosis because to research conducted in microgravity, Earth is benefiting from space medicine in the form of muscular atrophy, fluid balance issues, and more. Medicine, one floating test subject at a time, but we must also consider the psychological effects of living in space. Restricted area with just 6 other people, away from home, and on a rigid schedule. It takes a toll on astronauts to live with solitude and having nowhere to go, in order to cope with their circadian rhythms and the peculiar mental burden of staring down at their entire world. They stay linked to loved ones, adhere to meticulously planned routines, and discover significance in they read books, play instruments, take pictures, and yes, they watch movies as part of their job. Despite the unfortunate ban on popcorn, we can still enjoy digital pleasure. The longer we remain in space, the more we discover that humans are inextricably linked to gravity. It's a component of if you take away who we are, we start to gently and quietly fall apart. Unexpected grace, but we also discover our resilience and adaptability. We may be as clever as we can be despite the strange circumstances of floating in space. Odd, but it demonstrates the true magnificence of our Earth. Bodies will move from biology to technology in the upcoming chapter because we need more than just muscles to live and prosper in orbit. We also require machines from restrooms to airlocks, spacesuits, and solar panels. We'll examine the inventive innovations that enable life in space and the subtle ways gravity molds everything engineering choice for the time being. Take a deep breath and feel the constant pressure of your blanket and the surrounding air serve as a reminder that you are at home. Let's pause to honor something that isn't often highlighted in bedtime tales. Space engineering doesn't glisten, float, or even appear to be especially sleek. No warp motors or chrome fins, but that's the reason. Astronauts do not starve to death or spin indefinitely in the heart of space. Among all of this silent life, genius is a well-known unseen force. Tonight, we will examine how gravity appears to be lacking in space, still influences almost every aspect of our construction process, including the design of spaceships. From life support equipment to the basic space toilet, astronaut gear. Let's begin with a basic launch to get started. Gravity is the unseen engineer whispering in the background. You must first break free from gravity's hold in order to enter space, which requires an incredible when the Earth's gravity isn't interfering with your energy. You must approximately 11.2 kilometers per second, or 33 times, the speed of the escape velocity, sound. Therefore, rockets are basically controlled explosions with sharp. It is astounding how much fuel is required to launch a little payload into low Earth orbit. Actually, payload and crew make up the majority of what you see when you look at a rocket. Its fuel tanks are massive. Graceful propellant towers designed to push against the Earth's gravitational pull is the strongest and most consistent force we are aware of. And once you're up there, but gravity doesn't abandon you, it simply switches roles. Your spacecraft must cooperate with gravity rather than fight it to stay in orbit by balancing speed and altitude. Re-enter the atmosphere and change your position without plummeting or floating into gravity capsules in deep space even dictate a spacecraft's form, such as the blunt body design of those from Apollo or SpaceX assists them. They aren't pointed for pleasure. Survive re-entry by slowing down with the help of gravity and the environment. Generate heat and drag. Gravity takes over as the ultimate master at every mission concludes with an engineering physics and sheer material test. Let's enter the spacecraft now, where things grow more intense. In microgravity, every movement counts because it is sensitive, because there is no natural friction to slow things down. If you open a valve too forcefully, it may float away. If the bag is opened too quickly, its contents will be like glitter on a toddler's birthday party. Therefore, developers must create each tool's button panel and drawer for it to function. Velcro on everything and bungee cords for storage feet, unnecessary in the absence of gravity. Loops and handrails with color-coded labeling to help astronauts attach themselves, using tactile variations to help people locate items fast in a confusing setting where up doesn't exist. Even your typical drink pouch needs to be a feat of engineering because ordinary cups are ineffective. Since pouring is ineffective, fluids are kept in vacuum-sealed bags and sipped. Using special clamped straws is similar to sipping from a juice box made by NASA, which is basically it. Now, let's discuss air that you don't genuinely consider that you must bring your own air to space until it is gone. Maintain it moving, filtering, and pressurizing all the time. Earth's gravity aids in air movement. In orbit, naturally, warm air rises and cool air falls. Fortunately, air does not move. Space engineers created intricate ventilation systems with fans because it stagnates, and duct to maintain the flow of oxygen, carbon dioxide, and odors controllable since, yes, space can eventually smell more strongly of that. The life support system, which these devices maintain by controlling the temperature, humidity, and oxygen levels, is even more amazing. It's like living indoors while removing microbiological growth and trace gases. The fish in this high-tech aquarium are using laptops and treadmills. Speaking of treadmills, on Earth workout equipment like treadmills must be gravity independent. Works because there aren't many people in space and you're drawn down into the belt. Must use bungee harnesses to secure oneself, mimicking the sensation of body weight resistance equipment. Flywheels or vacuum cylinders can be used to simulate the pull of gravity, and these without them, it would be impossible to stop bone loss and muscular atrophy. Astronauts would return home as exhausted as overcooked spaghetti. So here is the part you've been anticipating. Restrooms. Yes, the most well-known unsung in microgravity. The hero of space engineering finds that conventional plumbing is ineffective. For water and wells, toilets employ vacuum suction to remove waste from astronauts because everything else floats. Must carefully aim, fasten the strap, and adhere to strict directions for filtering, purifying, and recycling urine into drinking water. NASA's tagline is "Today's coffee." A procedure that is more disgusting in idea than in reality is the coffee of the future. It is all a part of the closed-loop mechanism that sustains life. Waste that cannot be recycled is kept in bags and kept in a sustainable orbit until it can be. Yes, some items actually burn up in the atmosphere after re-entry, which feels even the famous white marshmallow armor spacesuit is a masterpiece of odd poetry. On Earth, a suit with gravity design may weigh 300. If an astronaut pushes off, the mass stays in orbit even though the weight disappears. Too much force could cause them to spin around. The suit is designed to give them air pressure and mobility. The astronaut can manipulate grasp tools and stay afloat while maintaining communication and thermal protection. Away, and in the event that they do float away, they have a contingency plan called a more secure type of miniature jetpack that enables astronauts to navigate back to safety with calming return with soft puffs of nitrogen gas that are neither dramatic nor ostentatious to their intended location, which is similar to figuring out how to go home after losing your way during a party in space. So yeah, although the lack of gravity defines space, our whole strategy for dealing with it is based on we launched to escape gravity's memory, which is built to defy it and replace it, and its influence is always felt by us. In fact, when astronauts return, they frequently fall under their own weight because home gravity is so strong. Feel lightheaded as their heart retrains to pump against pressure, or stagger when their blood tugs at their legs once more. According to one astronaut, it's like re-entering a planet that feels 10 times more. The most peculiar thing, according to a heavier person, was having to raise their arms once more because they had forgotten how it felt to be heavy. Gravity. It is still there in space. It's only hidden, subtly affecting each computation, every movement, and the silent engineer is always there, even when it appears like disappear. In our upcoming chapter, where we'll go back in time and examine the gravity doesn't exist in the universe itself. From the beginning of stars to the construction of galaxies, simply pull it to construct, mold, and form the structure itself. Universe. So allow your thoughts to wander now beyond the moon and the station, beyond the solar system, because to the unlimited reach of gravity in its, as we've seen thus far, gravity influences life engineering and even our capacity to shave while in orbit. But we have only been examining the local impacts at the human scale, Earth scale, station level scale. We must zoom out in order to fully comprehend gravity, since out there and not only is gravity a force in the vast expanses of space, but it also shapes the stars and galaxies are carved by the universe's very structure, directing the dance of cosmic structures that are too big for us to comprehend completely. Let's begin with a little astronomy. Conversing with a nebula, which is a cloud of gas and dust that floats in space by itself. Particles wander in tranquility until gravity gently intervenes, starts to gather particles, Some clump together, then some more as mass builds up as the gravitational force becomes more intense. The pressure at the A star's core gets so hot that it can start nuclear fusion, created as a result of gravity gradually drawing hydrogen atoms nearer until they are sun-formed by bursting into light. And this is how every another star in the night sky started out as a bright light that was condensed from a dust cloud caused by gravity's silent insistence, not with a bang, but with a scale up these slowly, as if the universe were taking a breath. Stars typically form in clusters that swirl together rather than forming alone. These clusters orbit each other and accumulate mass over time due to mutual gravitational pull, and ultimately they join something much larger than the Milky Way. Is home to some of gravity's most exquisite creations. Galactic galaxies, 100 to 400 billion stars. About a core bulge is encircled by spiral arms of gas, dust, and star nurseries. The stars are gravitationally joined together like dancers orbiting a cosmic ballroom. They're traveling at amazing speeds, but gravity keeps them from flying apart. Each connected star reacts to the invisible mass as well as its neighbors. At the center of the galaxy, which is made up of more than just dust and stars, however, there is a darker, more enigmatic substance that humans cannot see or touch. However, because galaxies rotate too quickly for their apparent mass to hold them together without some additional support, we know it exists. They would disintegrate, like leaves in a storm due to gravity, dark matter, etc. It exerts gravity, which maintains the Milky Way and galaxies intact. It is merely one among hundreds of billions of galaxies that are dispersed throughout the universe. The universe clusters into groups like luminous islands on a dark ocean, into superclusters that create a huge network on the cosmic scale, sometimes known as the cosmic web, and it's stunning. Galaxy filaments that resemble threads span unfathomable distances and connect at dense nodes where clusters are found. These structures aren't arbitrary. Billions of years of mass pulling on mass-forming patterns due to gravitational interaction ancient as time itself. But gravity may distort in addition to holding things together. Among Einstein's general relativity's most startling predictions is that not only do large items attract, but they also distort time and space. Light itself can bend due to bending. This phenomenon is known as gravitational lensing. Picture a far-off galaxy behind a huge cluster of stars. The light from a distant galaxy moves through the distorted spacetime in a curved path rather than in a straight line because of the cluster's bulk. The galaxy occasionally seems stretched and magnified to us, even replicated. Gravitational lensing has been utilized to find galaxies that are too faint to map dark matter, which can only be seen by the way it bends light in this way, and viewed directly, turns into a telescope as well as a sculpture. And then there are the enormous black holes, which are produced when huge stars collapse beneath there. They are not a cosmic vacuum since their own gravity is so strong that not even light can escape. Although they don't absorb everything, cleaners have such a strong sense of gravity that black holes cause light to bend and twist, and their effects extend well beyond their event horizons. Time and produce some of the universe's most intense occurrences. If they approach too closely, entire stars can be torn apart. But these terrifying objects are also vital supernovae at the core of almost all galaxies, including ours. Enormous black hole with a mass that is millions or billions of times that of our sun, although their formation is unknown. Their gravity stabilizes their galaxies. Without them, the elegant or observed spirals may not have remained intact. So dust storms too, from lensed galaxies to hidden giants. From spirals to clusters, starbursts is the mastermind behind it all. Because gravity plays the long game, it doesn't function quickly. It takes billions of years for the silent artist to create a galaxy, and billions more to direct stars along their orbits and, eventually, construct the vast cosmic, the universe-spanning web only shapes rather than shouts or rushes. Despite everything we know, there is still a lot we don't know about gravity. Ask a physicist what gravity is, but you can see it, measure it, and forecast its effects. Is in its most profound sense, and you'll receive a shrug. And then, as some people believe that gravity might not even be a fundamental force, arise from a deeper aspect of quantum reality that we haven't yet discovered. We'll talk about that mystery soon, but for now, keep in mind that gravity is visible when you gaze up at the stars. It created each point of light, sculpted it, and kept it in orbit. It pushed, bent, and steered the photons that made it to your eyeballs in every direction. Gravity leaves its trace at every distance, as we have been explaining. For the most of this journey, gravity acts as a sort of invisible rope that holds apples, astronauts, and galaxies together, established. But in 1915, Einstein arrived and revised the guidelines with Albert Einstein had a gleam in his eye and hair that defied all known forces. When he published his general relativity theory, everything changed. Simply how we perceive gravity, but also how we perceive space and time. And yes, it does get a little odd, but fear not, we're going the picturesque path. Let's begin with an example. Picture the cosmos as a huge piece of elastic fabric, like a bedsheet. The fabric will droop if you put a hefty bowling ball in the middle. Now grab a marble. It curved toward the dip when you roll it across the sheet. Not because of the bowling, the marble just follows the curve of the sheet as the ball pulls it. In short, this is the straightest path it can take, which also happens to be curved. Is how Einstein explained the gravitational pull of large things, like planets. The fabric of space is bent by stars and black holes, allowing other objects to pass through. Curved spacetime suggests that our perception of gravity is purely human. You're not being drawn to the Earth as you follow these curving lines. Instead, you're following space's natural course, which coincidentally dips toward Earth, is not precisely how Newton envisioned it. Einstein believed that Newton's gravity was a force operating at a distance. Geometry, a planet orbits because it is riding, not because the sun drags it, like a skateboarder in a curving course across space and time, enormous invisible bowl. And sure enough, time and space are involved, not just space, for, according to Einstein, time and space are not distinct from one another. Rather, they constitute a spacetime and four-dimensional continuum. Spacetime can distort that. Indicates that time moves a little more slowly in places where gravity is stronger. Isn't theoretical. Measurements have been made, and your phone's GPS system needs to adjust for due to this effect. Satellites in Earth's orbit feel a little less gravity than those on the ground to make their clocks tick a bit quicker. But without that adjustment, you're given that it turns out to be flexible. Navigation could pass by Killam every day. Your brain matures slightly more quickly than your feet while you're standing on a mountain. Sufficiently noticeable, however, when exposed to high gravitational forces for extended periods of time. Now that the difference is quantifiable, picture yourself close to a black hole and something so enormous that, as you get closer, space-time is severely warped. If you're closer to someone, time seems to move more slowly than it does for someone farther away. You could spend minutes while years go by for someone outside without being torn apart. One of the more peculiar effects is gravitational time dilation. The most poetic outcomes of general relativity also result in some extremely. The concept of dramatic science fiction was famously employed in the film Interstellar. It may seem unbelievable, but 1 hour on a planet close to a black hole is equivalent to 7 years. Einstein's equations have been tested and proven correct by math checks. And light bends around stars once more, and clocks tick in new ways. In Gravity Probe B and other orbit space-based studies have studied the twisting and warping of the new discovery of gravitational wave ripples in spacetime, even caused by large objects such as merging black holes, has validated his hypotheses. 100 years after Einstein's prediction, these waves were first discovered in 2015. Like pond ripples, they compress and extend time as they move by. But despite being millions of times smaller than an atom, the influence when scientists measured them using tools like LIGO, it was similar to hearing them for the first time. The hum of the universe is not merely explained by general relativity. We can see the boundaries of blackness and the hearts of stars through the movement of planets, holes, and the universe's beginnings. But it's not flawless, as even if Einstein's theory is effective, there is one point at which it fails. General relativity in the quantum universe at the size of atoms and particles begins to fail because it is incompatible with quantum mechanics, the other main tenet of current physics, which has prompted researchers to work for decades to combine the two to look for a quantum gravity theory that describes how gravity functions at the smallest possible scale. Thus far, we have concepts such as quantum gravity, string theory, and loops, but no conclusive responses. It's like having two maps that are exactly the same, 4 cities and 1 for forests. But general relativity is still not clear enough to determine how to draw the path between them. Continues to be among the most sophisticated and precise theories ever developed. And it's the fundamental realization that gravity is geometry rather than force has changed the way we conceive about the universe. Isn't always obvious. In fact, it's quite strange. However, the universe merely offers to be real. It makes no claims to be intuitive. And sometimes reality is stranger than we thought. So let's pause to think. This implies that you are sitting on a planet and are lying comfortably wherever you are. That causes space and time to bend. Your weight isn't a force drawing you in. Down is what happens when you follow a curved spacetime route that culminates at the floor. Each star is curved spacetime in its own area, and the light has been molded by unseen warps in cosmic time from faraway galaxies. It flows variably based on the universe and your location in time. A moving, undulating fabric with a huge field of curves is anything but static, and extends and dips controlled by the geometry of unseen strings rather than Einstein reportedly remarked. Reality is just an illusion, though an extremely persistent one, and perhaps the most persistent illusion of them is gravity. Not a pull, but a road, and we're nearly there. In the upcoming chapter, will I move from physics to philosophy to consider whether gravity is a basic characteristic of an emerging phenomena, nature, or something even odd that might not exist at all until we attempt to measure it. But that is currently a more complex riddle. Let's take a moment to relax in the gentle reminder that the cosmos is dynamic, that we like stones on a cosmic sheet, and that they are fixed but slightly twisted are just we have followed gravity by following the curves of something far bigger than ourselves. From the sensation of weight on your chest to falling apples, to whirling galaxies, we have trusted it to be woven into the very fabric of spacetime, and even Einstein helped to rethink it as geometry. But what if gravity isn't real? Not real as we perceive it, but what if gravity were constant? Presence upon which our universe has been constructed is not a basic force, but rather a type of illusion, a consequence, or an emerging characteristic of something more profound. Philosophers and scientists have been speculating about that issue for years. And tonight we'll gently explore that peculiar area where the rules haven't been established between hard science and soft speculation. Let's start with a word about being completely settled and the possibility that gravity is even odd than we've thought. In science, anything is considered emergent if it results from the actions of smaller components, even though those don't appear to exhibit that tendency when temperature is taken separately. The temperature of a molecule is zero, yet billions. What molecules are moving in a chaotic heat-producing motion is not a fundamental phenomenon. Rather, it's a now examined gravity as an emergent characteristic. What if gravity, such as temperature, which arises not from a force or even from spacetime curvature, but from a more fundamental perspective? This is the core of one of the more extreme theoretical physics entropic gravity theories put out by physicist Eric. According to Valinda 2011, entropic gravity implies that gravity results from systems' thermodynamic propensity to maximize entropy as a measure. According to this theory, gravity is neither a force nor even a source of disorder or information. When objects rearrange themselves to retain the most likely configuration, the result is known as the geometric effect. Watching marbles roll to the bottom of a pyramid when it comes to knowledge in space, bowl because it's the most stable and statistically likely option, not because they're being pulled down. Arrangement. Don't worry if it sounds abstract. You wouldn't see this by throwing a ball or feel it when lying in bed, but it may, theoretically, provide an explanation for some of the more puzzling modern physics problems. We only observe a small portion of the universe's matter, particularly dark matter. Galaxies rotate too fast for objects to be held together by their apparent mass. Dark matter is the term for the unseen extra-gravity at work, yet we haven't discovered it yet, even after decades of looking. But according to Varinda's theory, we may not have to if gravity is emergent. Perhaps our equations are just incorrect. The additional gravity at galaxy scales might represent a peculiarity of spacetime's behavior when entropic forces rule. There are no particles or dark matter halos, only a change in the way we comprehend gravity at this time. Entropic gravity is debatable and not yet extensively acknowledged that it hasn't taken the place of Newtonian physics or general relativity, but there is a hint that gravity may not be what we believe it to be. This is further developed by other concepts, such as holographic principles. The holographic concept suggests that the whole three-dimensional world we inhabit could be a type of like a cosmic projection, a 3D reality recorded on a 2D surface. Holograms are not science fiction. Rather, they are a real possibility that emerged from the black hole thermodynamics. Research showed an odd finding. The quantity of the amount of information or entropy that a black hole may contain is not proportionate to its volume. However, the information regarding what goes into a black hole may be different depending on its surface area, being coded on its event horizon rather than inside, which prompted physicists like Gerard Leonard Susskind and Huff to suggest that perhaps that is how things operate. Perhaps the cosmos is a projection from a more basic two-dimensional reality, and, if so, indeed, gravity, our beloved companion, might simply be a consequence of this. Projections create the appearance of pull rather than a force or curve, originating from deeper formational rules. Thus, it's crucial to take a moment to our thoughts, ideas, and possibilities rather than facts. Although they originate from actual math, from actual experiments and the boundaries of what physics is currently capable of observe. And they pose important queries regarding not only gravity but also what consider reality this way. For ages, humans thought the Earth was flat since it seemed flat, but after learning it was round, we found that it spirals, circles, and spins through a galaxy that travels through the expanding cosmos. Each step altering our perception of physics. But we weren't the focal point weren't motionless, weren't even fastened to a stationary frame, and suddenly according to scientists, even gravity, which thought to be the most dependable force, may be simply one more layer in a deeper, more enigmatic structure that we encounter but have not yet fully recognized. That it's similar to discovering upon awakening in a home you've spent your entire life in that the walls might be projections, the furniture's patterns, and the flooring, illusions created by the rules you cannot see. Yet that does not imply that you fall through the floor. The illusion persists until gravity quits acting, which is a very helpful. Apples continue to fall Newton, planets continue to revolve, and illusion GPS continues to work. Even yet, Einstein remains correct in their own fields. It's only that outside of there might be more in the future. So what does this all mean for you? The universe might be deeper if you're lying there falling asleep. More complex and unfamiliar than we ever thought, which is why you feel like you have weight. Perhaps the cosmos is being pushed toward balance by the gentle pressure of entropy. which keeps your feet on the ground because data favors it, indicating that science is not yet complete. Every response raises further queries, and every theory is a flashlight in a corridor with additional doors and gravity, which is more than just a force. Look closer, I might be something else. Is a mystery that invites you to in the last chapter. We'll go back to where we started, not coiled up or floating in space, within black holes. But once we're back on Earth, we'll consider the significance of gravity for our position in the cosmos and how something so silent and unseen can keep everything together, including us. Instead of in the frigid void of space, we find ourselves back where we began, slipping through curved spacetime or drifting past the ISS's solar panels. However, back on Earth, in your chair, in your bed, somewhere much closer to home. When we started this voyage, I was in a peaceful dark corner that was softly held by gravity, requested that you picture yourself floating outside the International Space Station to visualize the oddly lovely feeling of weightlessness. I asked a few questions as you were gently tumbling and seeing the Earth roll by beneath your feet. Minor queries. What exactly is gravity and what occurs when we abandon it? Behind and what can we learn about this unseen power that governs us from space? Perhaps the most truthful response is that, after 10 chapters, it tells us that we now know that gravity isn't as great as we once thought, and it may even be less than we thought. In space, it only conceals the fact that the astronauts are not floating behind motion, because they are descending flawlessly for eternity even though there is no gravity. Everything, including furnishings and food, needs to be redesigned inside that orbiting cocoon to function without the downward. The fact that our bodies are also creatures of gravity is something we take for granted. Without it, we extend, inflate, and lose our sense of direction. Even we get perplexed, but we adjust by using treadmills attached to we learn to exist without the very thing that shaped us. Like the ceiling in toothpaste squeezed from foil pouches. And later we zoomed out. We could see how gravity shapes galaxies from clouds and produces stars from. We had a glimpse of black holes, which connect galaxies into webs that span the universe and our light years of emptiness. We heard the hum of spacetime itself when gravity was king. After the emptiness was disturbed by gravity waves, we turned left into, in Einstein's theory, gravity is viewed as a curve where time flows rather than a force. Varies according on your position, as space bends like fabric and light, the intangible peaks and valleys. And we continued to dip our explorers in tropic gravity holographic universes from a philosophical perspective, as well as the disorienting notion that perhaps gravity is only the appearance of something more profound, and the pull we experience is a whisper in each layer of this trip from the mathematics of information itself. Gravity never stopped forming the world, sometimes loudly and other times quietly. Narrative. But what have we actually discovered? Perhaps this gravity is related to the link between matter and matter, between person and planet. Between planet and star is the web that enables cooperation in a universe that seeks to grow apart. There wouldn't be any stars, planets, or buildings without gravity. The cosmos would simply be a mist of lonesome particles without gravity. But gravity says, come closer, stay together. And that's such a basic concept that strong resonances that go beyond physics because, when you consider it, gravity is not the only unseen force that keeps everything together. Along with kindness, curiosity, and wonder, brought us here, you and I. Perhaps you began this movie in an attempt to doze off. Perhaps you were merely inquisitive, seeking clarification, or simply seeking some peace and quiet to keep you company when night fell. For whatever reason you chose to stay. You accompanied me while we navigated star nurseries, black holes, quantum problems, and coffee-recycled space toilets that allow your thoughts to slowly drift. Hello. If you're still awake, I hope your pillow is comfortable and cozy. Your mind is clearer than it was before we said goodnight, and I want to revisit the silent query I posed at the start of our adventure. Where in the world are you listening? Where are you now, and what time is it? Are you in New Zealand? In Canada, where the forests are located, the stars are inverted and the ocean is constantly murmuring. Inhale peacefully beneath the snow, or maybe on a couch and curled up in a bunk bed close to someone who has already gone to sleep. Perhaps you're sipping a warm beverage at 9:30 p.m. or perhaps it's 2 o'clock. Sleep is still elusive in the morning, or perhaps you're listening in the afternoon. You closed your eyes and allowed science to take you elsewhere for a however. Gravity ties us all together regardless of time or location. The same force that governs the moon, holds the oceans, and shapes the earth also holds us to it. Stars, and even when we gaze beyond the spiral arms of Saturn and beyond its rings, it makes no difference that we are still a member of the same invisible thread in our galaxy. Even though we're small and don't fully comprehend everything, we're curious and here. Gravity, whatever it is, serves as a reminder that we are all connected. Connection. So this evening, when you take deep breaths and allow your body to gradually sink into the convenience of home, keep in mind that gravity is holding you in place and that you are not falling. Comprehension by the mere act of being interested enough to pick up new knowledge, and if you have liked this voyage, perhaps that is sufficient. I would love for you to feel more peace and quiet, Please like and possibly subscribe to Science and Slipper's intriguing explorations of the universe. And if you haven't informed me in the You Never Know who might leave a comment about where you are and what time we started. I appreciate you sharing this moment since someone else might be dozing off next to you halfway around the world. Good night and good gravity with me.